Hello. Good morning. It's Aubrey. I'm Aubrey Digital. But today, I am Aubrey Logical. Alright. Alright. Okay, we're gonna see if we can't stop the blow up. Okay, I don't know why that's open. This certainly doesn't need to be open. Jesus, come on. Alright, here we are. I'm gonna... It's kind of like, do we really need the top of the camera? Like, what is this for? Okay, so I'll just point it down. Bear with me, please. Okay, so I don't quite understand. I don't quite understand why. Okay, I think we're better. We'll see. We'll see if I glitch. We'll see if I glitch. You were supposed to see this. Okay. So, I'm Aubrey. Let me see here. Oh, I guess I could have kept that like that. Can't believe it's taken so long to render each frame. I don't know why. I've never had music going before at the same time. So that might be why. Okay. Well, I can't really see my logo that good. Let me see if I can fuck with it. Ooh, can I put a mask on it? That'd be sick. I don't fucking know. Alright. Good morning, good morning, good morning. Welcome to my channel. I am Aubrey Logical. And I'm trying to figure out where to put this damn thing. You know what? We could just put it up here. How about that? Even better. Better than everything. Fabulous. So let's do some calculus, why don't we? Okay. So okay. So this is another technique for finding anti-derivatives. So first thing we're going to want to decide which function is which in this problem. So we have two different functions. We have an x, and then we have an e to the x. And these two functions are multiplied. So for u, let's go ahead and make it x, because it actually becomes easier after we take the the derivative of it, which is what that is. The derivative of x just becomes 1, because each time you take the derivative, you remove a power of x. So this leaves us with e to the x as our v prime. Now e to the x's derivative is e to the x, and e to the x's antiderivative is also e to the x. Now, we have a formula. It varies ever so slightly from the one that you'll find everywhere on the internet, but it's via my professor, and it is u times v minus the integral of v prime times, or of u prime times v times dx. So this is going to be our integration by parts formula. Okay, cool. So let's go ahead and just move this here. How about that? Because then we'll be able to see it for the next problem too. Okay. So now we just plug into this formula. So we're going to get x times e to the x minus the integral of u prime multiplied by v times dx. So this simplifies to e to the x. Like I said, our antiderivative of e to the x is also e to the x. So, oops. Now that we have all of our integration taken care of, we just need to add our arbitrary constant number. And that is our answer, folks. I think my stream got better since I abandoned the that's good. Gosh, I could still go lower, but I guess I don't really need to. Maybe I could sit back. Is that gonna? Yeah, I don't really need to sit. It doesn't matter. I can, I guess. All right, we're figuring this out together. I was gonna share this with my group in my class, but I was like, I don't know how much they'd appreciate this, considering it's not like they can join in, really. I mean, they can make comments. All right. We're going to the next problem. It's really not that complicated of a process yet. So let's go ahead and u is going to be equal to x again, which means u prime is going to be equal to 1 again, which means v prime is going to be equal to the sine of x, and our antiderivative is going to be negative cosine of x. So, putting it all into our formula. Oh, I don't know what that shouldn't have been there. Okay. So x times v minus the integral of v prime times of u prime, sorry, times v times dx. Okay, so now we integrate negative cosine of x, and we're going to get positive, no, actually, just kidding. Since we're doing the antiderivative, we're going to stay negative, and we're just going to become sine of x. And since we have taken care of our integration in that particular instance, our answer is as follows. Let's see if I'm able to do this. So here's what I'm listening to. Not my music. But it just sounds nice. I like it, something with a good beat. I think this is supposed to help. I don't know. Sometimes music doesn't help me. Sometimes music doesn't help me one bit, and sometimes music is everything. Let's see, how... Yeah, I'm not very loud back here. Let's move this back here. Back here! There we go, now we're louder. Okay, we're back. And we're back. Onward and upward. Number 3, x times the cosine of x dx. Okay. Unbelievable. Okay. Alright, so sorry to keep y'all in the dark. Damn, this is sick. This song. Alright. I used the wrong color. Oh well. Minus the integral of u prime times v times dx. Not too difficult, I don't believe. I mean, who knows? I could have gotten all these wrong. I haven't exactly checked. They haven't posted the answer key yet because these assignments. Oh shit! These assignments I don't do yet. I should stop doing this. Okay. Darn, darn, darn. Well, I'm sure it doesn't matter. Who gives a fuck? Nobody knows this channel's here, right? There's nobody chatting. I haven't had any views. Yeah. Fuck it. Fuck it, fuck it, fuck it. But I could probably get in trouble for this. Yeah, I should probably... I don't know, maybe I could just do similar problems? So... So this one's kind of a doozy, because it doesn't look like you need to use integration by parts. It looks like you can just find the antiderivative of ln of x, which would just be wait, I think the derivative of ln of the antiderivative of ln of u is, I think, u prime over u. Oh, duh. Well, that wouldn't be 1 over x. That would just be 1. But that would be the derivative. But I thought the derivative of ln of u was u times u primed. I'm confused. Anyways. Fucking math. Anyways. Long story short, the whole reason I confused myself is because I was trying to say that we do need integration by parts, even though it does appear to only be one function. It's actually two, somehow, some way. Because... yeah, ln of x is going to get easier. So when ln of x turns into 1 over x, it changes what kind of function it is from transcendental to algebraic, or actually not algebraic, whatever the fourth one is with the division. Okay. So that leaves v prime to be 1. And v to be x. So now let's bring our formula with us. Okay. So we've got ln of x times x minus the antiderivative of x over x dx, which x over x simplifies to 1. Let's write this x over here. The derivative of 1 is just going to be x. Moving on. Okay. Next problem is x squared times e to the x dx. I might be wrong. Yes, it is. I don't know why I said one thing and wrote the other. Okay, so here's our integral. Jeez. All right. Once again, we've got two functions. Not sure which case this would be. It is an algebraic and a transcendental. And its derivative doesn't get easier. So I guess it's case 2 because its antiderivative doesn't get any more difficult. So let's go ahead and write our formula out. So usually when the formula is of type 2, the power x's raised to will tell us how many times we have to do integration by parts. So we clearly have to do it one more time. Let's pick, yep, okay. Two x is just going to become 2. E to the x always stays e to the x, no matter which way you derive or whether you integrate or differentiate. Let's rewrite our problem now. Times e to the x minus, now we got integration by parts, so we've got u times v minus the integral of u prime times v times dx So now we've just been reduced to one function because the 2 is just a coefficient. So to integrate this, the 2 comes outside of the integration, and then we just do e to the x. The reason this is a plus is because we have a minus to a minus. And our derivative becomes to e to the x. Plus c. Moving on. x squared times sine of x dx. Okay. Not really grabbing this because I need it. I just think it's helpful. If people don't just think I'm pulling this out of my ass. Alright. So the derivative of u is going to be 2x. The antiderivative of v is going to be negative cosine of x. Now we can do x squared times negative cosine of x minus the integral of 2x times negative cosine of x dx. And again, we're going to have to do integration by parts twice. All right. Let me move this a little bit. Leave some room for our declaration. So u is going to be 2x, which means its derivative will just be 2, and the derivative of v is going to be cosine of x, negative cosine of x. And v will become negative sine of x. So using our formula, we've got 2x times negative sine of x minus the integral, oh wait, yeah, okay, I'm doing this wrong. Integral is going to be over here now. And then we're going to do u prime times v times dx, which we are going to be rewriting this now. Alright, so minus minus is going to actually be plus 2x times sine of x. Let's see, the derivative is negative 2 sine of x, so the negative 2 comes outside. Well, at least the 2 comes outside. So negative negative, so that's going to be a plus the derivative of 2 sine, which will give us the antiderivative of minus 2 cosine. Oh, wait a minute. Yeah, no, that's what it would be. Okay. Gosh, these beats are so nice. Alright, y'all, I'm not sure if I did this one right. X squared times sine of x. So it's negative x squared cosine positive 2x sine positive 2 cosine minus x squared cosine of x plus 2x sine of x minus, no, plus 2 cosine of x plus c. So I was wrong. Okay. Oops. Just trying to figure out. I get why that becomes a plus. Okay, so we have this inside of our antiderivative. So to integrate, the antiderivative of negative 2 sine becomes positive 2 cosine. But then it should be minus positive 2 cosine. Or so I would have thought. Anyways. Because the antiderivative of sine changes the sign of the function. I don't know. I got questions about this one. Right here. Right here. Moving on. Let's do number 7. Number 7 is Lx times the ln of x. Okay. I'm not gonna go get our formula anymore because we should know it at this point. All right. Not sure if I picked the right approach, but let's check it out. So maybe we'll do ln of x times x squared over 2 minus the integral of u prime times v times dx antiderivative of x squared over 2. That becomes a 3. So that becomes 1/6. And I can already tell this is not correct. I mean, unless I just didn't get this far on my assignment. But this doesn't look right. Let's try it the other way. I just don't know what the antiderivative of ln of x would be. Like, oh, that would be a, yeah, that's an integration by parts. Duh. I don't know. Let's go look. Maybe I didn't get this far. No, I didn't. Well, I guess we'll go check it then. Who knows? This could be right, but something doesn't seem right about it. Okay. X squared times ln of x over 2. X cubed over 4 plus c. Just used. Okay. So I did pick the correct approach, but I didn't do it right. So let's try to figure out what I did wrong here. So we can pull the 1/2 out in front, and then we are just taking the antiderivative of x squared dx. Which would be times, should be 1/6. I mean, unless I just made a really dumb mistake. Alright. We're calling in the big guns. Or at least slightly bigger guns. Alright. What was it? X times the ln of x. Ha! No, I was wrong. How the fuck is it 1/4? Okay. Okay, x times ln of dx. U, x. So 1 over x, okay. V, x squared over 2. Got it. I got that right. And I got that right. Right? Oh, wait a minute. Wait a tick. What am I doing? That's 1 over x, not 1. So then that becomes 1 over x. Oh my god, that changes everything. Okay. Okay. So now this would cross out that x and cross out the squared on that, so that would just become x over 2, I believe. Could still take the 1/2 out front, and then we just have the integral of x dx. So then we can rewrite as ln of x times x squared over 2 minus 1/2 times the antiderivative of x is still x squared over 2. So for a final answer, that's going to give us we know it's right now, so we can circle it in the right color. Cool. Alright. We're back to glitching, but that's okay. On to the next one. Let me see if I can get to number 10, at least. Eight. X cubed times e to the x. Okay. Okay. Alright, so I just noticed that our exponent is 3 for our x, so that means we're probably going to have to do integration by parts again, which means I'm going to bring this down here a little bit and find myself a couple different colors. So okay, so and do minus again, and it's going to be 6x times e to the x minus the integral of 6 times e to the x. As we can see, this is going to satisfy our usage of this method, because now we're only left with one function with a coefficient. This is a long problem. Let's go ahead and rewrite it all, because I think we just got it right. Thank you so much for your help. I couldn't have done it without you. Watch, I'm probably wrong. Alright, the antiderivative of six to the ex is going to be 6 to the ex. So beautiful people, that is our answer. Let me check us out here. So it is x cubed times e to the x dx. So x cubed times e to the x dx. Let's see if it knows what I'm trying to say. Alright, I'm lazy, so I'm just going to screenshot it. Alright, moment of truth. x squared e to the x minus 3x squared e to the x. Oh! I missed one of my signs. How the fuck? I don't understand. Where would that negative come from? I don't understand. There's not... Unless... Oh, because we had to do integration by parts twice, maybe? So that there should be 2? But shouldn't that change the sign of this one too? Interesting. Alright. 2 more to go, and then I'm going to call it a day. 9 x squared times cos of x dx. Okay. Plugging into our formula. Yeah, it must have been what it had to do with that second integration by parts. That must have turned it into a positive right there. Yep, that's what it was. Okay. Should have become a positive right there. Yeah, and that would do it. Okay. Glad we got there. Probably still missing on the test though. Okay. Cool thing about doing this a whole bunch is that it just becomes easier. Like I don't even really have to think much about what I'm doing after I've done this enough times. So the antiderivative of sine is going to be negative cosine. So let's go ahead and... This might be the last time we have to rewrite this one. Can only fucking hope. Okay. Oh, just kidding. Alright, let's do 2x times negative cosine of x minus the integral of 2, that's good, times negative cosine of x. Okay. I love these beats. So the integral of -2 cosine of x becomes -2 of sine x. So it would be a minus and a minus, so it should be a positive. That should be right. X squared times cosine of x. Yep. Okay, plus 2x cos. Oh, damn it, it's minus. Okay, so the rationale behind that... Fuck, every time. So the rationale behind that is if we are taking the integral of -2 cosine of... No, sorry. -2 cosine of x. We're going to bring the -2 outside, and we are going to find the integral of cosine x, which is going to give us sine of x. So -2x cos x minus sine of x, but it's still there, so it's going to become minus minus minus. So if it was just minus minus, it would become plus, but since it's minus minus minus, it goes back to negative. Super confusing. One more. We're doing one more today. Thank you so much for hanging out with me. Just doing math over here. Trying to ace this calculus 2 test. X times e to the 2x. X times e to the 2x dx. All right. So we've got e to the 2x. So to find the antiderivative of e to the 2x, it's basically just going to be e to the 2x again, but then we have to counter the chain rule, which is 2, which is the derivative of this expression, which is 2, so 1/2. Now we can go ahead and copy into our formula. Oh, I used the wrong colors again. Oh well. I don't think I'm going to need integration by parts twice this time. So the integral of 1/2 times e to the 2x. So it should just be... Alright, let me kind of try to walk you through that. So when we're doing the integral of 1/2 e to the 2x, first we're going to pull our 1/2 out front, and we're left with e to the 2x. Deriving e to the 2x, it's just going to be e to the 2x, and then we counter by our chain rule again. So we're going to have 1/2 times 1/2 e to the 2x, which is going to become 1/4 e to the 2x. And that looks right to me. So pretty much so far, when I mean so far, the toughest part of this assignment is getting your signs right. Yeah, well, I don't know how long I've been going. Let's see here. The one just disappears. Oh, I've been going over an hour. Okay. Cool. Well, hey. I hope this was not a total snooze fest. Sorry, I meant to be more like instructional. It's just like after you do this so many times over and over again, it's like you're like really like it just becomes so second nature. Like I want to do. I can't believe I haven't got stuck yet. Too bad. I mean, I wasn't right, I guess, but I haven't got stuck too bad. Okay. X squared times ln of x dx. So for this one, we're going to want to make our u this function because it's going to simplify. When we take the derivative, it's going to become 1 over x. So then v prime is x squared, and v is okay. Plugging into our formula again. U times v minus the integral of 1 over x times x cubed over 3, which is going to simplify for us into x squared over 2, the integral of x squared over 2 integral of x cubed over 2, we're going to make that a 3, and then we're going to divide 1/2 by 3, so it's going to be 1/6 X cubed plus C. Final answer. Let's check it out. X squared times the ln of x dx. Hey. I think I got it wrong. It's because I wrote it wrong. I tell you, I make such silly mistakes sometimes. Alright, so then that becomes 3. Key change flip. And I did say minus, right? Yeah. Cool. So that's close. See, it's always the silly little mistakes that are the death of me. No, not the death, but you know what I mean. The downfall. How about that? Thank you so much. If you come check out any of this, I am just putting in the time so that I can hopefully oh my gosh, get a pretty good score in this class. That's the goal. Anyways, I love you so much, and I'll be here tonight at 10 p.m. Well, not here, but on my other channel, aubrey.digital. Well, okay, I'll be at aubrey.digital, and I'll be on my YouTube channel at Aubrey Digital. For now, I have been Aubrey Logical, and have a good day.